Alright, class, we're going to talk about finding an equation of a line when you're given a point and a slope. In order to do that, the best way is to use this formula called point-slope form. And it's handy when you're given a point and a slope to use point-slope form. Now, what we're actually plugging into in this formula is just the y1 and the x1. So we're given a point, negative 2, 8, and we plug them in to the y and the x. Now remember, this is just like slope, where this is our x1 and this is our y1. And then we're going to get y alone, and we're going to finally get our answer in y equals mx plus b form, because this is the standard equation for a line. So let's work it out with this particular problem. So we've got y minus our y1, which is 8, equals our slope, our m, which was 2, times x minus x1, which is negative 2. And again, the formula y minus y1 equals m x minus x1. So you can see where I plugged things into. And now all I have to do is get y alone, so I add the 8. I get y equals 2, parentheses, x. I'm going to change the signs here, plus 2, plus 8. And then I distribute my 2, and I get y equals 2x plus 4 plus 8. And then I just further simplify, and I get y equals 2x plus 12. That is your final answer. That's the equation of a line in slope-intercept form. Given a point and a slope, you start point-slope form, finish in slope-intercept form. So now we're going to be given problems that are asking you to do really the same thing in point-slope form, but they give you 2 points. Given 2 points, we still need to find our slope, and then, using one of the points, we use our point-slope form. So I find slope using the slope formula, which is m equals y2 minus y1 over x2 minus x1, and I get 8 minus 4 divided by 5 minus 3. And then I simplify, and that's going to give me 4 over 2. If I reduce my 4 over 2, that's going to give me 2. So my slope, my m, equals 2. So now I have slope and I have a point, so I just use point-slope form. So now I've got m equals 2, and I pick one of the 2 points. It doesn't matter which one. I usually like picking the smaller one. So I do y minus the 4 equals, the m is 2, parentheses, x minus 3, and then I just solve for y. So y equals 2, parentheses, x minus 3, and then plus 4 on the outside. And finally distribute the 4, or the 2, and simplify, and I get y equals 2x minus 6 plus 4, and further reduced, I get y equals 2x minus 2. So they give us 2 points. All they're really trying to do is just give you a point and slope, but you actually have to work a little harder to find the slope this time. And we want to work a little bit even harder now on problems like this, because they're going to talk about parallel lines and perpendicular lines. Now, parallel lines, as you can see here, I've counted slope out for each one of these lines. Parallel lines have the same slope. You've probably heard about parallel lines before and say, oh, they don't touch, or they look like railroad tracks. Well, that's true, but the real algebraic definition is that they have the same slope. So if you count rise and run for each of these lines, the red line and the blue line are parallel because their slopes are the same, 3 over 4. Now, perpendicular, the pink line is not perpendicular. This line is not perpendicular. Perpendicular is a little bit different. Perpendicular has a negative reciprocal slope. What that looks like is if I had a slope of, like on the other problems, these were 3 over 4. So if I had 3 over 4 was my slope, the slope perpendicular to that would be the negative reciprocal. Reciprocal means flipped, so you flip it, 4 over 3. And negative of that would be negative 4/3. This would be the negative reciprocal slope. So let's try a couple. If I had 1/2, the negative reciprocal of that would be negative 2/1. You flip it and change the sign. If I had negative 5/7, that would be 7/5 would be the negative reciprocal of that. Okay? So just a couple that you can check back through if you get confused later. So what they're trying to do here, sorry, this is supposed to say parallel. Okay? What they're trying to do is just another type of problem where they give us an equation, this one's parallel, and it says it goes through this point. Well, this equation is another line that we don't actually care about. We only care about what the slope is for this line, because if we have the slope for this one and we know our line is parallel, then again they're trying to just give us a point and a slope so we can use point slope form. So what that means is we got to use this equation to solve for y, and if you do that you're going to get to move the 2x to the other side, so I get 3y equals negative 2x plus 6, and then if you divide by 3, you'll see that your slope is y equals negative 2/3 x plus 2. The slope is negative 2/3. That's all you cared about. So basically what they're trying to do is say, since your line's parallel, then what you're really looking at is this point, negative 3, 6, and m equals negative 2/3. So they're really just giving you a point and a slope like we were given a couple problems ago, so that we can use the formula, the point slope formula. Y minus y1 is 6 equals negative 2/3 is our m times, so negative 2/3 times x minus negative 3. And then we just need to distribute and simplify. So I take my 6, add it to the other side, I get y equals negative 2/3 x plus 3 plus 6, and then distribute my negative 2/3, and when I do that I get y equals negative 2/3 x, and then when I multiply the 2/3 and the 3, I'll do it in the top right corner here, I get negative 2/3 times 3. The 3 is really over a 1. That means you can cross cancel those and multiply straight across, and that's going to give me negative 2 and then 1/1, so it's just negative 2/1, which is just negative 2. So again, negative 2/3 x minus 2 plus 6, which is going to simplify to be y equals negative 2/3 x plus 4. And that is my equation in slope-intercept form using, when I know that my line is parallel, not perpendicular, parallel, a different equation, trying to find the slope from that equation so I can use point slope form. Now this is my last one where I have perpendicular, and so it's just a little bit extra step, but we're given the same equation and point here. So what we're supposed to do, it says this time that it's perpendicular, so we take our slope. Remember the equation was y equals negative 2/3 x plus 2, and so what we care about is this slope. Well, this isn't our slope this time, this is our perpendicular slope. So if our slope is perpendicular to negative 2/3, what we're supposed to do is flip it over, and our slope is going to be 3/2. As we flip it over, change the sign. So now this is our point, and that's our slope. So I use that to use point slope form, which is y minus 6 equals 3/2 x minus 3, and then I just solve for y. So I get y equals 3/2 x minus 3 plus 6, distribute my 3/2, and that's going to give me y equals 3/2 x, and then when I multiply 3/2 times 3, it will just multiply to get negative 9/2, and then plus 6. Now to actually add the 6, I need to make common denominators, so 6, if I multiply top and bottom by 2, that's really going to turn into 12/2, And to add these, you actually subtract negative 9 plus 12, so you're going to get 3. So where am I going to write my answer here? Let's erase this right here. I put my answer, y equals 3/2 x plus 3 over 2. So that'll be your final answer. So again, the goal here, when they give you the perpendicular line or the parallel line, you're really just trying to find your slope, use the point, and then use point slope form.